disinfectant bag. Wash your hands to be clean and safe.
Good morning, grade 11s. We are still busy with mensuration, and now we are looking at volume and surface area. First we did perimeter and area, and now we're looking at the volume and the surface area. But you will see that this is then more difficult shapes, not so easy as you've been doing up to grade 10. So we're marking now, try now 35. Try now 35. Find the volume and the surface area of the figure. So the volume of number 1A is then just length times breadth times height, which is what? 7,500. Make sure that you write your units in every time, cubic centimeters. Now we're looking at the surface area. You will remember that is my box. I've got two sides, and the bottom and the top. You've got 6 sides, which means that it will be 2 times 10 by 30. Plus 2 times 10 by 25, plus 2 times 25 times 30. And what is that, Rein? (2,600 square centimeters. Square centimeters then there. 2,600 square centimeters. Right, number B. This one is a cylinder. What is the volume of a cylinder, Anna? Pi r squared h. These are the formulas that you still need to know out of your heads. So if we just substitute pi, the radius is then 2 squared times 3. And Anna, what is that one's answer? 37.7 cubic centimeters. Cubic centimeters. And then, now what is the surface area? And this is then 2 circles plus that part there. And I showed you this paper. If we have this paper, the circumference is the length. The circumference is the length there. So don't get confused here, because you sort of think you should work with pi r squared. So it will then be 2 squared plus, and the circumference is then 2 pi 2 times 3. This one's answer, 62.8 square centimeters. Square centimeters. Right, number C. Now this one, and now I think you should really look here, because now we've got its volume, so it's 3-dimensional, but you also have that triangle there at the top there. Okay, so in the first place, the volume will then obviously the volume of the rectangle plus the volume of the triangle. And we said volume is face area times length. So you will calculate the face area and you will multiply it by the length. Face area times length on these shapes. So what is this one's face area then? What? 23 by 5. If you want to multiply there already with the length, you can do it and work with them separately. And the triangle is then half base, which is 8, times the height of 3, and the length is still 10. What is the volume? 1270 cubic centimeters. Cubic centimeters. So face area times length. Okay, now let's look at this one's surface area. Now, let's just look at the shape again. if you have to calculate the surface area, what do we have? We have a bottom base, two sides, a front and a back, and then that part which is only smaller, isn't it? This part where the triangle stands is not part of the surface area because you don't see it outside. Think about you painting it. What are you going to paint then there? So the surface area will then be 2 times 23 by 5 plus 2 times 10 by 5. And then what is the base? 23 by 10, isn't it? 23 by 10. But then that's only one of them. And then we've got this top part there, which is what? 15 by 10. So plus 15 by 10. Could have subtracted it, but we can just calculate it like that there. Okay, as Ashley said, this is a very large sum. Now we take the triangle, and there you have the 2 front faces, so it's 2 times a half of base, which is 8, times the height, which is 3, isn't it? And then there's also those 2 rectangles at the side, isn't it, Janu? And what are they? 3 by 10. So there's also 2 3 by 10s. And this will be the surface area. So who's got the answer? Christian? I thought you can do it out of your head. Melissa? 834, yes. So the surface area is 834 square centimeters. Square centimeters. But that's how we're going to do it. Okay. I'm also going to mark try now 36 now. And the following sums is now word sums. And if I look at them, a lot of them come out of old question papers. So this is the kind of thing that you're going to get. So we look at number, try now 36, number 1A. That's very easy. Calculate the volume of the tank. So Pesci, that is then just length times breadth times height. Okay, which is what? 6,000 cubic centimeters. How many cubic centimeters in a liter? How many cubic centimeters in a liter? 1 liter is how many cubic centimeters? 1,000. 1,000 cubic centimeters. This is these milk jars or that you get, a mug, that we have there. Okay? Then we look at number B. Now we're working with a cylinder. The diagram shows the cylinder and we calculate the volume there. Right, Sunay? We said again the formula is pi r squared h. Remember, you will get no marks for formulas. You get marks when you substitute in a formula. That's what you're going to get. Right, Sunay? Okay, but it's just rounding or not rounding. Give me your answer. 4? Cubic centimeters. The book just rounds it off to 3 significant figures. You can give it like that. It must just not be less than 3 significant figures. For more, they give marks. For less, they penalize you. Okay, and then we say number 2. Now we're pouring the water in the cylinder. So it's this volume that you're pouring in the cylinder. And find the total volume of water now in the tank. So it's just the 2 together, isn't it? The volume of the cylinder, that's very easy. 10,400. This is a rounded one now. So you can mark an unrounded one also correct in there. And the last one, calculate now the depth of the water in the tank. So what do you need to calculate? The height, isn't it? So we're still with this formula. Volume is pi r squared h. And the volume is now 10,400. The radius is still 10 centimeters. And you have to calculate the height. And what did you get? 13.9. And this will now be centimeters because it's just the height that we have now there. Okay, let's look at try now 37. Try now 37. In the diagram, it shows 3 circular holes. And what happens here is we work with letters, not just with values, but it will work exactly the same. Explain why the shaded area is 80 minus 3 pi r squared square centimeters. So how do we get shaded area? We said that now several times. Shaded area is the big one minus the small one, and in this case it's 3 circles. So the area of the big one will be 80, and this is then pi r squared. We don't have a number there, so you just use the letter. That's what you had to show. Can you see? Okay, now we come to number B. When R is 1.93, calculate the shaded area. So now I can just use that formula, substitute the 1.93 in there, and what would be that area? So you just work with this one. You don't need to calculate it again. 1.93 in R. So this is then 44.9 square centimeters because it's still area. Number 2, the shaded area is a percentage of the total area. So again, very easy, 44.9. What was the total area? 80 times 100 over 1. So that's how we get the percentage. Marley, I rounded off there. And then number C1, calculate the value of R when the shaded area is 55. So now we're using that one, shaded area that we had right at the beginning, 3 pi r squared, and it is now equal to 55 because that is the shaded area. So minus 80, divide by 3 pi, and you root it eventually. Melissa, 1.63. And then the last one there, calculate the circumference of one of the circles when the shaded area is 55. So that means when the radius is 1.63. So we're going to calculate the circumference now, which is 2 pi 1.63, 10.2 centimeters.
He has to listen to the information. Now, that information needs to interpret it and then convert it, and that part of the brain will then absorb the information. I think it will be a huge opportunity.
What is your true purpose, and how will I commit as a leader to continue?
When you speak about the communication and how it's being received,
how do you relate to people? I mean, those respect, love, those are the crucial things before you build the solutions.
busy then with try now 37. We have to start with number 3. We already marked the other 2 in the previous lesson. This is a very nice example. This is old questions out of the exam papers. I recognize this one. So look carefully at this one here. It's a mixture of algebra and mensuration that we're doing now here. A rectangular open box, open so there's no lid at the top. That's important. And we have now those dimensions 2x, x plus 4, and x plus 1. That is your dimensions. Write down the volume of the cuboid. So volume is then obviously length times breadth times height. You will just see here that you cannot multiply 3 things at the same time. You won't be able to do that. So we are going to use extra brackets for that one there. What is the volume of this box? If you simplify it. Yes, 2x to the power of 3. That is, when we simplify, that is your volume there. Then expand and simplify your answer. That's actually the A2 then. Now we come to number B. And they say the box is made from plastic. So you've got this box and there's now an inner volume. Can you see? And they say it's 1 centimeter. So now you have to get new dimensions. Now if we look at this one, this is that length then there. Remember, there will be 2 sides, not only 1. That's a mistake that a lot of learners make. There's 2 sides. So, Jaco, what will be the first one? 2x minus 2, isn't it? And then the height here is x plus 1. Now, it was an open box, so that one will just have 1 side there. That one is then x. And the last one is, this one is x plus 4. Again, there's 2 sides, so that one will be x plus 2. So that is the new dimensions of the inside of the box. I subtract that 1 centimeter at each side. That's how I get that one. And now we have to find the volume of the inside of the box and show that the volume of the plastic is that. But let's first get the volume of the inside of the box. So it will now be 2x minus 2 times x plus 2. And we want to multiply it with x. Again, remember, you can only multiply 2 things at a time. So you're going to come back to this x. Otherwise, you make mistakes there. So, Jaco, what is your volume here for the interior box? It's a 1. It's not an I. It's a 1. It's in Roman counting. Yes? Plus 2x plus 4. Why plus? Isn't it minus?
Negative plus a positive times a positive equals to?
A negative. This is why I'm asking. Is she correct here, Sunay? No, a positive times a negative is a negative. So now you've learned a very important lesson here. Minus 4x. Minus 4x. That's why I'm saying you have to multiply that first and then come back to the x. Otherwise, you're going to make mistakes. Like terms is positive and unlike terms is negative. Now they're asking, how do I get this value here? It is the big volume minus the small volume, or the outside volume minus the inside volume that will give you the box, the volume of the box. Okay, so if I subtract the 2 now here, 2x minus this one, then you get a 0. 10x squared minus 2 gives me that 8x squared, and 8x minus 4x, 12x. And that gives us then the volume of the interior. You can't just leave it like that, Jaco. You have to show me how you get it. Then the next one is now B2. And now they say that this interior volume is 1980. So I can say that 8x squared plus 12x is equal to 1980. Oh, this is C. Okay, C1. And then they say, show that you get that and solve this. Again, you cannot just use it. You have to show that you get to that. So I will bring it over, 8x squared plus 12x minus 1980 is equal to 0. And then to show it, you have to show me with what are you dividing. And I'm dividing this whole thing by 4. You can show it like this or like this. That's showing what you are doing. I need to see that. And the final answer is then 2x squared plus 3x minus 495, and we have to equate it to 0 to solve this equation. So if you factorize this one now, this one will solve, and it is 2x plus 33 and x minus 15. That's the two values that you get there. So then we can say, obviously this one is going to fall away, isn't it? X is equal to negative, but you have to show me that you get it, because you have to solve it at that point, or x is equal to 15. And which one are we going to choose now? The positive 15. We're choosing the positive 15. So what will be, and then the last question is, what is the dimensions? And the first one is then 15. Okay, but still, 15 plus 1 is 16. And then the other one is 15 plus 4, so it's 19. And then 2 times 15, which is 30. And that's my dimensions, how I get it. Look at this question. I hope you followed what we are doing. Right, the next one is try now 38. Word sums. In every paper, there's always this long word sum on geometry that we have there. Right, Jane investigates cylindrical plant pots. The standard pot has a radius of r and a height of h. Pot A, pot B, and pot C. There you have them, the different ones. Write down the volume of the pots in terms of pi, r, and h. Right, so now we have to get A, B, and C. A1, A for Anna. So what is the first one? Finding the volume. What is volume now again with the cylinder? Pi r squared h. Okay, Anna, so the first one is? Yeah, not 9 pi r squared. Yeah, r squared h. Pi r squared h. So that one is the 9. 3 pi r squared h. And the last one is 27 pi r squared h. So working with letters, now you can simplify your ratio to be 3 to 1 to 9. That is the ratio. You get the volume and then you get that ratio. Then we say, which one of the pots, A, B, and C, is mathematically similar? What is similar? Same shape, different size. Elzine, which one is similar to? Yeah, pot C. Because pot C, look there, is 3R and 3H. So it's similar. The other pots is just the radius or the height is more. But by C, the radius and the height is in the same ratio. And then the last one, the surface area of the standard pot is S. Write down in terms of S, the surface area of the similar pot. So this is all about similarity. Now, which ratio are we choosing? C, which is 1 to 3, isn't it? So what would be the ratio of the surface area? No, what do we know about area? Have you ever heard about the square of the ratio of the sides gives you the ratio of the area? We did it with similarity. So it's 1 to 9. 1 to 9. The square of the ratio of the sides gives the ratio of the area. It's not asked here, but what about volume? The cube of the ratio of the sides gives the ratio of the volume. Right, question B. Very good exercises that you had to do. All are coming out of old exam papers. This is what you're going to get. Jane buys a cylindrical pot with radius 15 and height 20. She wants to paint its outside surface area, the base and the curved surface area. Calculate the area that she wants to paint. Now remember, it will be a circle, and we said, what do we know about the circumference or the surface area, and we said the circumference is the length, and there's your height. That's what you are using then there. And obviously that base. So what would this one be? The radius is 15, isn't it? Yeah, now we have to calculate it now. So what is the circle? Pi 15 squared plus, and what is that now? This length, 2 pi 15 times, no, times 20, not square now. This is why I'm showing you that that is 2 pi r. It's not square now. It's the circumference that you're talking about there. And calculate the area that she wants to paint. So what is your calculation, Ash? 2592 square centimeters. Yes, that's right. That's the surface area, the surface area. And then the last one, number 2, there, how many pots? Jane buys a tin of paint which covers 30 square meters. How many plant pots of this size could be painted completely on their outside surfaces using this tin of paint? So we have to can change that. You can either change this one to centimeters or then the other one to meters. I changed it like this. So this one is then dividing by 4 zeros there. 259215. I used the unrounded one, but they want complete ones, so it's 115. You get 115 point something, but you can't paint that other one. It's not enough. So, okay, you're always asking, why are you doing maths? These things are now very practical. Once you're going to paint for your dear little wife, Rain, something, then you must make your plans. Right, number 2. This is also a question that they love. Water flows through a pipe into an empty cylindrical tank. The tank has a radius of 40 and a height of 110. So there's the cylindrical tank that they pour in the water. Calculate the volume. And volume is then pi r squared h, which is the radius is 40 and the height is 110. So Maxine, what is the volume of this tank? 552. Yes, Maxine? 920, and this is square centimeters. Okay, but that's good enough to give it like that, to round it off. But actually we said first write down the unrounded and then round off. You use them in B. Yeah, that's volume. It's cubic centimeters, that's right. And then they say, but listen what I'm saying. First write down the unrounded one because you're going to use this in the next step. And then you must not use rounded stuff, but unrounded stuff. Right, number B. The pipe has a cross-sectional area of 1.6. So there's a pipe now coming in here in the dam. And it has a cross-sectional area of 1.6. So Armand and Melissa, we have that area there. The water comes out of the pipe at a speed of 14 centimeters per second. How long does it take to fill the tank? They love this question. Now, what we need to understand is that this area there, 1.6, times that per second forms volume. That area there times that what comes out in 1 second, that is the volume that we have there. So it's 14 centimeters per second, but that means that's the volume that comes out there. So that's why we're going at number B now to divide that 552,920 point, whatever you had there. And now we divide it by this volume, which is then 1.6, because this is the area, times that 1.4. And that is a concept that you need to understand, that area there times that per second forms volume, because not everybody realized that. So if we divide now here, Sunay, what did you get? What did I say? Oh, yeah. Okay, and then what did you get, Sunay? Okay, and then now we actually still have to change this to per second, isn't it? because this was in seconds and they want the answer in hours and